Assalamu alaikum. In our last lecture, we were doing the components from electrophoresis. We're solving a question from electrophoresis. We were sort of in the last example, and where we stopped at question number C and onwards. We did up until A and B, where we draw the structure of the tripeptide of alanine, serine, and glycine. And we found the MR of the compound alanine, serine, and glycine. Now, we were supposed to first find, like, the question was something like, sort of, this was a homework, but still, there were certain clarification to be needed. So I hope you tried. It doesn't matter if you have like succeeded in solving it or not, but it's completely fine. At least you tried. But now, the information which should be given is like in the first question, like in this, in let's say C number question, the question is actually finding F. Let me write it down here. You have to find at first F, G, H, and I. What are they? Now F is obviously this is power supply. That have been like said earlier. I is what? Filter paper. Fine. Now the difference between G and H, what should each of them be? Now, in order to answer them, we at first have to come back to, like, we have to move to the next question where it is given. I'm saying this in a reverse manner. Actually, this is question number D is given in, like, in the actual question paper. This was the first question, like this was the third question. Then the fourth question is explaining P, Q, R, and S. Okay, but to make things easier for us, to help us answer question C, to help us answer question like the third question, I introduced the fourth question beforehand. Like instead of like in actual question paper, this is the third question to find this thing, and in order to find PQRS, this is the fourth question. But we need at first PQRS to answer the third question. That's why we have been given, or I have given you the third question, like the fourth question in place of third question, and the third question in place of fourth question. Does it make sense? So like, even if you didn't get it, it's completely fine. You don't have to. But at first, let's see what are PQRs. We have to know at first what are PQRs. Before answering actually G and H, easily we can answer F and I. That's completely fine. That's answerable. But in order to answer G and H, we have to know at first what is PQRS. Now let's come here below, and at first let's see. Let's observe the portion. We do know in like in the mixture, when electrophoresis is done, the component exists by like after breaking, isn't it? After the breakage, the hydrolysis, they exist in the structure, isn't it? So based on their size, their mass, the travel, isn't it? So from here, what could be observed? P travels the maximum distance, so P should be the lightest, and S travels the shortest distance, so it should be the smallest. But see, observe, here we have, after breaking, only three components. One is alanine, another is serine, and another is glycine. But here we have been provided with 4 spots. Then how come that happened? Isn't it? That's the question. So the answer behind this is, actually these are the 3 components. And what is S? S is the heaviest. So actually S is the whole entire component. So there is a part, there is this component as well, like in the mixture, this whole of the component also exists. Now, why is that? Because C, this itself also is an amino acid. Why? Because see, here we have NH2 group and COOH group. This is not a polymer, isn't it? This is not a polymer. Rather, this is like a portion of, you can say like a portion of polymer. Polymer means what? There will be no more like bond formation linkage. Like you cannot form any more bonds. But here we have NH2. That means this still has the ability to form more bond. This still has the ability to form more bond if more monomers is added. But since that's not the case, so this itself is an amino acid, we can say. So that means this S is this entire molecule. If you want, you can take notes and write it down, like why this is the case. So this is actually the amino acid, one of the amino acid itself, because we have, like, after forming the peptide linkages, we do have the amine and the carboxylic acid group. That means it itself is an amino acid. And after that, when breakage is like, now let's come to the breaking part of the peptide linkage. After the breaking of the breakage of the peptide linkage, now we have PQR. Okay, clear? So PQR is the individual amino acid component, alanine, serine, and glycine, and S is the whole alanine, serine, glycine, like the peptide, the tripeptide molecule. Okay, now one thing they have mentioned is that the pH was at 11. Okay, pH was at 11. Now, before that, remember we talked about zwitterion in one of our lectures. Most probably it was it the third, like, I mean, the last lecture or the lecture before that? Let me see. The zwitterion's concept is required here. Just a minute, let me see. Yeah, so most probably in the last, second last lecture, isn't it? Third last lecture, the class before yes, the third last lecture from from the previous lecture. So it was like, let's say this is the previous lecture. Okay, so this is today we are now, this is the previous lecture, and the previous lecture. So that means from the last lecture, the previous, like the third last lecture, or from today is the fourth last lecture. Okay, so on that video you'll be able to find about the concept of zwitterion, which was actually the very last of the, like, last part of the video, last part of the lecture was about zwitterion. Now remember the concept of zwitterion. That means the amino acids are in their ionic state, like in any, actually when zwitterion forms in any of the pH value, zwitterions form, like the amine and the carboxylic acid, they dissociate ions, hydrogen plus, like H plus ion, some gain, like in amine, where amine gains H plus, so carboxylic loses H plus based on the pH value. Okay, now they have been given us what? pH of 11, pH of 11, isn't it? Now how things happen, let's see. Let's say we have the serine. Serine is what? Serine looks like this, NH, sorry, not serine, it's alanine. So alanine looks like this, CH3, COOH. Then we have, I've already drawn it here, isn't it? Why am I drawing it here again? So I've drawn it here. So this is alanine, this is serine, and this is glycine. Okay, now they are in this normal state. pH 7 means what? We're adding alkali, isn't it? So when alkali is added, alkali means hydroxide, what happens? The acid reacts. Which one of this is acid? This one is the acid. So this will react. This carboxylic acid, after reaction, what will be the component? CH3, COO minus, isn't it? Now over here again added like the hydroxide, what happens? The carboxylic acid reacts, amine remains itself amine. It doesn't, like, it does not bother. Finally we have OH minus, again like hydroxide reacting with whom? Now the this is glycine, isn't it? Yeah, glycine. So amine didn't react because amine is basic. It is like alkali. It is an alkali itself, like it's basic. And we also have added a base here. Base does not react with a base, it reacts with acid. So neutralization reaction happens, but this is the structure. Finally, we also have what? We have alanine, glycine, and serine. So this should be the structure. Sorry. Isn't it? And when we add an alcohol here, I mean, sorry, a base here, what happens? This H plus H goes and O minus remains, isn't it? That means what? Overall charge, observe it clearly, overall charge remains what? For this one, overall charge is what? Minus, isn't it? For the above one, what is the overall charge? Negative, 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 minus one, minus one, minus one, isn't it? So overall charge of all the molecules is what? Minus one. There's no positive charge or neutral charge in this case. And see, observe one thing. If they're negatively charged, all the molecule moves towards the G terminal, isn't it? That means what? Negative terminal, negative molecules, like negatively charged molecule, attracting to the to one of the terminal. Then what should be the charge of this terminal? Try to guess. Don't see here, like here are mistakes. Here we have mistakes here in the in this part, but try to observe, like negative charges are attracted by whom? Obviously positive charge, isn't it? That means G is what? G is the positive terminal, and node is G. G is anode. However, that means H is what? Negative. In our last lecture, I mean the last lecture where I was sort of describing this problem, I sort of forgot about the Zwitterans part. Okay, so I'm really sorry. I did lack some knowledge there, like back in the last lecture. So I'm really sorry for giving some wrong information. I'll sort of write down it on the description of the last lecture's video, but yeah, that's basically it. So this is the actual part. So that means what? In pH 7 we are having a charge of negative molecules, isn't it? They're showing us negative molecules. Why? Because the carboxylic reacted, lefting us with COO minus. Hence this is positive terminal, because negative charges are attracted to the positive terminal. Now things will be easy for you to answer which one is which molecule. S is the heaviest molecule, and heaviest we do know that all the three in a single compound is the heaviest. So S is what? Alanine, serine, and glycine. So S is ala, ser, gly, isn't it? So this is S. Now what is P then? P is the lightest. Lightest of them are whom? If you calculate the MR of, let's say, individual amino acids, then you would see that glycine is the lightest. So this is gly. Okay, P is gly. And depending on, like, the rest of them are Q and R. So Q and R is what? Q should be, we have alanine and we have serine. It is observable from the R group that CH3 and CH2OH. CH2OH is heavier. That means R is what? Serine. So R is serine, and alanine is Q. So Ala. So that's how it was needed to be solved. So that means we got our answer, where P is glycine, Q is alanine, then R is serine, hence S is ala, ser, gly. Okay, so that's basically it. And officially we are done with our organic chemistry syllabus. So from our next lecture, we will be moving on to analytical chemistry, which you will see we will be working with organic chemistry, but we won't learn anything new. Rather, we will take such compounds. So let's say this compound, and we will analyze those. Let's say we will observe, like, for example, experimenting. Okay, which component is, based on experiment. Like, for example, X-ray, or like IR spectroscopy, mass spectrometry, HNMR. Like, we will be, let's say we don't know a certain molecule, and depending on certain technical experiment, we will sort of identify what each of the molecules are. Okay, so that's all for today. See you in the next lecture. Assalamu alaikum.